Okay, for today's video, we are talking about matrix basics. Now, I know right here it says number 3. Your entry may be different depending on when we are viewing this, where we are in our notebook. So our standard today we are talking about is MM3A4A, which is talking about doing operations with matrices. So first off, you need the definition of a matrix. So a matrix is a rectangular array of numbers. Matrices are also named using capital letters because you got to think mathematicians, they get tired of writing the same matrix over and over and over again. So if they can, they're going to abbreviate in some way, form, or fashion. So for example, we have this matrix right here, and we are calling it letter A. So if we were doing a whole lot of operations, we could always say we're going to multiply by A. We were going to try to find the determinant of A, all these different things of A instead of writing out the 6-term matrix. The next thing you need to know is how to find the dimensions of a matrix. Now, the dimensions of a matrix are the number of rows that go across and the number of columns that go up and down that the matrix has. And for example, right here we have a 2 by 3. In order that they found the 2 by 3, we have to know how many rows go first. And so if you think we have one row going across here, and we have a second row going across here. So there are 2 rows. The 3 represents the number of columns. So it's always rows times columns. So if we go through, we have one column here going straight up and down. We have a second column here going straight up and down, and a third column on the end going straight up and down, thus a 2 by 3. This one over here tends to trick people because you just look at it and you think, oh, it's just a column. It's just a 1 by 1. But if you look, I do agree that it does have the one column going straight up and down, but each number resides in its own separate row. So we have 1, 2, 3, 4 different rows. Thus, we have a 4 by 1. Now, pause this for a second, give it some thought, identify the dimensions. All right, so this first one we have 1, 2 rows. This is a first number is a 2. We have 1, 2, 3, 4 columns. We have a 2 by 4. Second one here, it does kind of look like a square. That's a specific type of matrix, and we will get into that more another day. So we have 1, 2 rows, and we have 1, 2 columns. Square matrices will always have these 2 numbers matching, which is really pretty cool. This one down here, we think it's a square, but let's double check. So we have 1, 2, 3, 4 rows, and we have 1, 2, 3 columns. This is actually a 4 by 3 because it has all these little negatives. It spaces it out a bit more and kind of tricks you. So you got to be careful of that. All right, next thing we need to know, since now we know how to make a matrix, how to classify a matrix, we need to know how to add and subtract with them. Now, it is only possible to add or subtract 2 matrices if they have identical dimensions. That means they are the same size, they have the same number of rows, the same number of columns as each other. So that's very important. Now, to find the sum, we're going to add corresponding entries. That means they must be located in the same row and the same column as each other. So essentially, they need to be in the same position. To find the difference, we're going to do the same thing. We're just going to subtract. So in our first example right here, let's go through and count, make sure we can do this. We have 1, 2 rows, 1, 2, 3 columns. We have a 2 by 3 going on. Check the next one. We have 1, 2 rows, 1, 2, 3 columns. We have a 2 by 3. The 2 sets of dimensions match, so we can do this. Then we go through position for position and go through and add. So we have 2 plus 4 does equal 6, and the answer goes in the same position. And if you go through, we have 0 plus negative 8 is negative 8. 7 plus 1 is 8. Negative 4 plus 9 is 5. And 5 plus 5 is 10. And 1 plus 0 is 1. Let's look at the second example right here. You can always see it tells you that it's not possible. So let's go through and check the dimensions just to make sure. So in this one, we have 2 rows and 1 column. So we have a 2 by 1 going on. The next one is a square. So we have 2 rows and 2 columns. So it is not possible because the columns do not match. So make certain you know that. All right, 2 examples. Take a minute, give them a shot. Okay, so we got to go through position for position. So we have 3 plus 6, and they're both in the upper left-hand corner. So we should have a 9. Next, we have an 8 plus 7 should give us a 15. In the bottom left, we have a negative 7 plus a 2 should be a negative 5. Then we have a 5 plus negative 4 should leave us with a 1. On the bottom, make sure you keep track that that is a subtraction sign. So we have 67 minus 2 this time, so we have 65. 43 minus 1, so that's a 42. Negative 72 minus a negative 5. Now remember, anytime you subtract a negative, change it to adding a positive. So we end up with a negative 67. Then we have 300 minus 0 is still 300. There is one more matrix basic we're going to talk about during this video, and that is scalar multiplication. Now, a scalar is a real number, and you'll always see it because it will be over here in front of the matrix. Now, to multiply a scalar by a matrix, you're going to take the scalar and we're going to multiply everything in the matrix by it. So we're going to take 3 times the 2, and its answer goes in the same position, the 6. And we just go through and we distribute and repeat. So then 3 times 0 is 0, makes sense. 3 times 7 is 21, makes sense. 3 times negative 4 is negative 12. 3 times 5 is 15, and 3 times 1 is 3. And that sums up our basics of matrices for today. Next video we'll be talking about matrix multiplication.